So unit 2, balancing. In this balancing, we discuss about the balancing of rotating masses and the balancing of the reciprocating masses and balancing of the locomotive engines. So first you have to know what is meant by balancing of rotating masses. The process of providing the second mass in order to the counteract the effect of the centrifugal force of the first mass is called the balancing of rotating mass. The following cases are important from the subject point of view. That is a fourth thing. One is the balancing of single rotating mass by a single mass rotating in the same plane. The second one is the balancing of single mass by two masses rotating in the different plane. The third one is the balancing of different mass rotating in the same plane. The fourth one is the balancing of different masses rotating in a different plane. So first one, when the balancing of the single rotating mass by a single mass rotating in the same plane, that is the mass is rotating in opposite direction, we have to place the same weight at the same radius. Okay, that is used for balancing the single mass rotating in the same plane. That is formula, the equation is m1 into omega 1 square into r1, that is equal to m2 into omega square into r2. The two masses revolving at the same angular. Okay, that's why we have to equate omega 1 square equals to omega square. That's very integrated. Finally the equation is m1 into r1, that is equal to m2 into r2. The second one is the balancing of single rotating mass by two masses rotating in the different plane. So we have to balancing by using the two things. One is the static balancing, another one is the dynamic balancing. The net dynamic force acting on the shaft is equal to 0. This requires the line of action of three centrifugal force must be same. In other words, the center of the mass of the system must lie on the axis of rotation. This is the condition for the static balancing. The net coupled due to the dynamic force acting on the shaft is equal to 0. In other words, algebraic sum of the moments about any point to the plane must be 0. The conditions 1 and 2 together give dynamic balancing. The following two possibilities may arise while attaching the two balancing masses. The next one is the plane of the disturbing mass may in the different between the plane of the two balancing masses. The plane of the disturbing masses must lie on the left or right of the two planes containing the balancing masses. When the plane of the disturbing mass lie in between the plane of the two balancing masses. Okay, so this is the pictorial view we have to mention here. The next one is when the balancing of the disturbing mass lie on the one end of the piston of the balancing masses. So this is another one. Next one is the balancing of the several masses rotating in the same plane. So this is a space diagram and this is a vector diagram. By using the vector diagram, you have to identify the how the balancing mass should be placed and what is the masses magnitude and where you have to place. By using the graphic representation, we have to identify the problem. So this is the A mass, this is the B mass, and it's rotating in some radius, and this is the distance between the A plane and B plane is 300 mm, and this is the C mass. Okay, this is revolving at some radius, and the distance between the A and the C is 400 mm. The next one is the D mass, and the distance between the A and D is 700 mm. The next one is we have to balance this A, B and C and D. So we have to add some balancing masses. The balancing masses is Y and H. Now the Y is 200 mm from the D plane. Now the H plane is the distance between the plane X and Y is 400 mm. So now we have to draw the angular diagram. The distance between the A and the angle between the A and B and this is the C, and this is the D. So we have to, so this is the force polygon diagram. By using this diagram, we have to easily identify the what is that forces acting in the, by using this thing you have to, the red color represented, this is the unbalanced masses, so acting in this direction. And this is the coupled diagram. By using this diagram, we have to identify unbalanced disturbing masses and measure the line, and we have to calculate. Okay.